Hi all. So in this video we are going to learn about how we can reverse a singly linked list. So before that we'll see how we do the traversal. In a singly linked list we can traverse only in the direction of the given arrows, right? So if we have a singly linked list of 4 nodes, so for the 4 nodes we can traverse only in one direction like this, right? Because we have the addresses like that, we can't travel backward. And of course this is one of the limitation of this singly linked list. That is why we have gone for a doubly linked list. But here if you say that if you want to reverse a singly linked list, that is you have to move this arrow in the opposite direction, right? So this way. Okay, and let's suppose we have this pointer head pointing up to the very first node. So this head needs to point, this link needs to be broken. Here we need to put null somewhere to make it as last node, and this head should point to the last node, and this pointer needs to be updated with the previous pointer at previous node address, right? So this is going to be somewhat trickier. So first of all I would like to illustrate it using a simple example. So for doing this we need to just fix the links between the nodes. Okay, so let's say we take 3 pointers. Let us name them as P, Q and R. Okay. Now R will contain our head address, that is, let's say 100. Okay. Now R is 100. So Q should be point to 200. Of course, if R is 100, Q is 200, means R is here and Q is here. Okay. Now what is the significance of this third pointer P? I'll tell you. So first of all we have this R as 100. We'll check this. This is the node, and in Q we have 200. So what we'll do, we have to update this part. Okay, this is the next of R. So in the next of R, okay, we need to do for the first node we are doing. So this is for the first node. So in the next of R we are updating the value to be as what? Let's say null. So for that, this value can be used. We can update it as P because P is null. So simply we can say that the next of R should be P. Okay. Now what we need to, we can't just remove this value as it is. So somewhere we need to store it. So this value is stored where? In Q. Okay, and we need also the address of this node because we have to update this address here in this node. Okay, so this node address is present in R. So what, after updating it, this R next to P, we are going to put the value of R to P. Okay, now P contains 100, and then we have to move this pointer R to this place, so we can update the R to value of Q. So now R is updated to Q. Okay, so now R now points here and to the second node, and we have P as R. Okay, so here we need to update this pointer, of course. So this pointer would be replaced by this address, of course, and this address is already present in P. So what we'll do, before doing this, we need to update our Q also because the Q will be the next address here, this node. So Q will be updated to let's say 300, and so in the next step, what we will do, like we have here R as 200, Q will be updated to 300, the next of R, and P will contain the value of R, that is 200. Okay, so that sorry, P was initially having 100 from this. Okay, so in the R dot next, that is in the next of R, we are updating the P value. So what we are doing, we are updating here 100. Okay, so this link is broken and a new link is born. Okay, and what we are doing next, we are putting the value of R to P, and in R we are updating it with Q. So we are putting here 200, and in R we are updating it with 300. Now let's come to 300, that is the third node. So this one. Okay, so this is our R is here. So our R is here, our R is at 300. So definitely our Q will be at 400, and in this we have 200, that is the P. So you understand the significance of these three nodes, these three pointers, sorry. This P contains the address, this Q contains the address, and this R. So somewhere this 200, then 300, then 400. So this way we can have the address of the three nodes, three consecutive nodes simultaneously. And in the update, what we are doing, we are updating the next of R, that is the node with address 300. We are updating the next as 200, that is, sorry, P. Okay, so in the next of R, we are updating it as 200. So this link is broken and another link is born. Okay, and then we are, what we are doing, we are moving this we are updating this P as the value of R, so that we can have this 300 address alive. And then we are updating the R as the value Q, and then we are further moving as it is. Okay, so what we are doing here, we are moving this R to this place. Okay, now we are at the fourth node, definitely. So at the fourth node, we have this R as 400. We have Q as the next of R. So Q is pointing to null. And we have P, in which we have the value currently as 300. Okay, since we have updated here 300 from this step. Okay, so this way we have all the consecutive nodes like 300, 400, and null. So we'll do the update here. So what we'll do, in the next of R, we are updating P. So in the next of R, we are updating 300, so that this link is broken and this link is born. And then we are doing what? We are updating a P equal to R. So this 400 is gone to this, and for the R we are updating it as Q, so R now points to null. Okay, so when R points to null, we will come out of the loop, and we have P as 400, that is our new head. Okay, so it is as simple as that. We can see this in program as well. I just have illustrated it using the steps, how we can do this via the three pointers. So automatically what you can understand here from this, that if we have these nodes, let's say there are three nodes in a linked list. Okay, this way. So if we have this node as 100, 200, and 300, let's say this is our last node, and this contains a linked list like this. Okay, and there is a head containing this address. So what we are going to do here, that we will be having three pointers, like to update this link. If we are updating this link is affecting actually three nodes. If you're not seeing, this link is affecting three nodes: this node, and of course this contains the address of this, so this node as well, right? So three nodes are being affected by changing one link. Okay, so it's not about just two nodes. We have to look for the three nodes update, the three nodes part as well. So one will be pointing P, one will be Q, and one will be R. Okay, that is why we have taken three node pointers here to hold the addresses. Like one node will be holding the address 100, one node will be holding the address 200, and one node pointer will be holding the address 300, right? Simultaneously. So that what will happen, that if we are updating, we don't miss some addresses here, because any of the address, any of the link is broken, we can't move forward, right? So this is an explanation to what we have already seen in the code and what I already explained in the earlier video. This is very important and the most frequently asked question in most of the interviews because it involves a little bit logic here. So how you are updating this links. So in order, if you even forget this, so please remember that when you are updating the links, you need to have the three pointers. Okay, one pointer, let's say R. Let's not confuse with the pointers again. So let's focus on the same part. So if you have this pointer R somewhere and R is pointing to your first node, that is if R equal to you assign head, so you will be traversing while R, okay, while R is true. And what you will be doing, like for R, you need to have a Q that will be pointing to the next of R. So Q will be having the, if R is having the 100 value, Q will be having the 200 value. And what will be the value of P then? It won't be 300 right now. Since we are tracking this part, so it involves three address 1, 2, and 3, right? This 1, 2, and 3. So P will be having the address of R only because this 100 is contained in R. Okay, so this is P. Now what we'll be doing? We will be updating the value of R this way. So initially P should have the value of null. Okay, so P is having initially the value of null. We will be updating it in the next step, right? So before that, we need to put the value of null to this part. So there will be one more step here, and there what we will do, that we will put the R next equal to P. Then we will update P to the R part. Okay, we'll update the next to P, and then we will update it with the P value to R, and then we will move the R to Q. Okay, so this part is important, and then we can move forward. So you can just think of this example and correspondingly update the pointers accordingly. Okay, so that's the end of this video. Thank you very much.